Hey everyone, Mr. Hostler here. What you guys have been working on the past couple days are some basic energy transformations. You guys used the energy skate park and saw that at the top of the half pipe you had a lot of gravitational potential energy, and as he was falling down that ramp, that gravitational potential energy was being transferred to kinetic energy. So the next two activities, activities 3 and 4, well, the one with the belly flop Benny, the guy that is on the high dive, as well as the roller coaster problem, you guys are just going to get more practice with that energy transformation and doing some calculations there. So to kind of look at that, we are going to take a look at a student or a kid on a slide here. So if a student started down here, forgive my drawing skills, that in the smartboard is not properly oriented, but this person would have 0 gravitational potential energy. This person would have 0 kinetic energy. They're just stationary. They're not moving. Well, as they climb up the stairs, they would be doing work against gravity, lifting themselves, and now they have gained gravitational potential energy. Now we could calculate that gravitational potential energy by just doing mgh. So let's just kind of make up a value here. I think 1,000 joules of energy sounds good. So let's say we have 1,000 joules of gravitational potential energy at the top of the slide here. Now we know as they go down the slide that gravitational potential energy is going to get transferred to kinetic energy. So at the bottom of the slide here, once they've met the ground here, all of that gravitational potential energy that was originally 1,000 joules at the bottom would be then transferred to kinetic energy. So at the bottom of the ramp, all 1,000 joules of energy would be in kinetic energy. If we wanted to solve for things like, let's say, velocity, we could set our 1,000 joules equal to our kinetic energy equation, 1/2 mv squared, and solve for the velocity. Now, some basic things that you guys are going to work through. Let's say we are at half of the maximum height, so we'll say h divided by 2. We know at that point half of our energy at half the height would be in potential, so we would have 500 joules of energy there, and half of our energy would be in kinetic when we're at half the height. So you guys will have to do some calculations based on just making some energy transformations and using our formula mgh and 1/2 mv squared to then solve. Other than that, I think you'll find these to be pretty straightforward activities, and these energy transformations are going to be really big going forward and starting